Hi everyone, welcome to Digital System Design. So today we are going to be discussing about one of the sequel concepts which is on denormalization and normalization. So denormalization and normalization are pretty simple and basic concepts probably which everyone knows about it and they have heard about it and they know how it works internally, but they are not sure like where they can use the denormalization concepts or normalization concepts for the benefit of their implementation. Now, whenever somebody is working on any of the products, so and they have to choose some kind of data storage system, so they preferably go for an SQL based database. It can be Oracle, it can be MySQL, it can be SQL Server, or it can be any other system which support RDBMS principles. Now, here comes the next part, how they have to design their database such that it is scalable enough to handle at least or suffice your NFR requirements, and the database should have a good relationship among the different tables so that your performance of your pages should actually be at par based on your requirement. And secondly, it should not be such that your database is too much overloaded with different requests and it's taking so much time to respond back itself to your requests based on its structure. Now then comes the two different concepts. One is normalization and other one is denormalization. So let me coin those terms here. So the first one is denormalization. The second one is normalization. So these are the two terms. Now comes the what is denormalization and what is normalization. So first of all, we will take the concept of normalization. Now let's say you are taking your basic example of an e-commerce application where you are creating a table or table structure to store the data related to the products in the cart or which user has added the products in the cart, for example. Now let's say you create one table which is having cart ID, sorry, cart ID, then it has created timestamp. Okay, then what all things it needs what all products it has. So it means one cart ID is related to multiple products. So when we talk of normalization, it means what normalization is. So first of all, let's define that if some of the audience of this channel is not aware about what is normalization in the database concept. So normalization is nothing but actually uh, putting your redundant data into separate tables such that it is not duplicated anywhere, and if you have to change the data, you will change it only one place and it will be referred to other places automatically based on the entity relationships. So let's say one table is maintaining your one entity related data in that table. For example, the first table that we demonstrated here, so that is on the cart table. So the data which is inside this table, which only be demonstrating the data, is confined to the cart. So let's say what is the cart ID, what is the created timestamp, and who created it, and basically when it got updated, how many products it has, all those things. But there is something other metadata relations also. For example, how many products it added, each product, how many quantity added. So all those things are also there part of that cart. Now, if we put everything in one table, so it means one table is creating or holding multiple entity relations. For example, cart ID, product ID, user ID, and all that. But when we talk of normalization, it means one table has to hold the data of one type of entities. It can be cart. It can, if it is a product, it is a product table, product related information. If it is user, it is user related information, and so on. So in the similar concept, so we'll be extending this table. Let's say this table is holding only the cart information, and this table is holding the information of your product information related to the carts. So let's say this is your cart ID here, and then you have product ID, how many quantities you have added in the product for that cart. So that is the minimal data which we can have, and then we can have another table which can maintain the data of, for example, user ID. Now each card, let's say one card is having one user ID, so it will be tied to one relation, and then each card will have multiple products. So this relation has one to many in this table. So basically, we have disintegrated that complete data into three different tables. Now, what will happen if you on the UI you have to show all that data in the collaboratively way on the UI when you have to display the cart information. So you have to display the product information, you have to display product image, product quantity, and when it was added or something like that, who is the owner for it, and all that. So to display all that information, you will have to join all these three tables and get the required data, or probably some more tables if we need some other data also related to those products in cart. But as for right now, you will have to join these three tables and get the required data. So that is basically normalization. So you will have to put the data into different tables based on your entity or actors, and then you will have to probably join those tables and get the data for you. Now, the basic challenge over here is the joining part. So, when your data gets huge, so probably joining is one of the challenges which you may face. And in terms of performance improvement, so there you can improve the performance by indexing those fields and such that it is better to join those data and get the data quickly. So, these are some of the ways probably which you can implement. So, those ways we'll not be discussing in detail, but we are just discussing when you should use normalization and when not to use normalization. Then comes the other scenario, the denormalization. Now let's say if we put entire data that we have here in the one table. So we'll have product ID, quantities, and then user ID, then created time, and all that. So now all that data is in one table. Now if you see, if let's say you have five products in one card, so you'll have five rows here, and each row will have redundant data for user ID, created time, and quantities and product ID and all that. So although product ID and quantities were already redundant in this table, not redundant, but actually they had duplicate or different product IDs. But user ID and created timestamp will be redundant here because each time for each product ID you will have to add the user ID also. But now what is the advantage here? You will have an advantage. The joins will not be there. So you will not have to join these table with the other tables to get the data. So in that sense, it is faster. But now what are the challenges or differences between these two? Okay, let's make a bit smaller. So let's say the first challenge in the denormalization cases. Let me put it here so that it's clearly visible to everyone. Holding too much of data, too much of redundant data. Of course, if you are holding, in this case, you are holding too much redundant data for user ID and the created time. Then, secondly, if you have, let's say, you update product ID or product information, for example, in the master table, you will have to update that in this table as well. Basically, there is no one copy of that entire entity. So product as an entity should have one table only where the entire information should be there. Now, if we see the denormalization case, probably we'll not have only product ID here, we'll have product name, product description, and all that stuff because to avoid joins, we'll have to add all those columns here as well. Because if we'll keep product ID here, so then it will be abiding some of the principles of normalization also. So to avoid that, to avoid all the joins, so we'll not add product ID here. We'll have only product name and product description and similar way username as well. So now in that case, if tomorrow somebody updates the product information in the product table, for example, we have product table here, we have product ID, we have product name, description, quantity available, and all that stuff. Now if somebody updates it here, so it will not, they will have to update here as well in all the cart related rows. So that is actually additional work which they have to do. So, but in this case, when you are working on the RDBMS systems, so it's better to follow these kind of principles when you are having transaction related data, for example, cart, or for example, adding or deducting something from the bank account and crediting to some other things. So, if you have some kind of transactional use case in your implementation, so then you should go for normalization implementation. But if you have something related to, for example, analytics, and if you just want to show the analysis values or just want to show the final output, let's say if you booked something in the cart, so what all attributes are there in the cart? Cart ID, your product name, description, if you want to show all those things, so then it's better to use the denormalization concepts, because in that case you need not to refer to other tables to get the required information, because you are not maintaining transaction, you're just displaying the data based on your uh, analytics use case or something like that. So prefer denormalization or prefer normalization first, I should say. Then you have transaction related use case. It can be transaction or it can be relation. We can say transaction or related relationships to be managed. Then you have prefer denormalization if you have analytics related use cases. These are the two differences and when we should use it preferably. Now the next point comes in some of the examples. For example, now when we talk about transactions, so what kind of databases are they? Are they only relationals or are they what? So they are basically nothing but OLTP. OLTP is transactional processing databases. And what are analytics ones? Those are OLAP, which can give you the data quickly for different multiple of fields. Let's say you need analytics of data, let's say for 100 or 200 of fields to display to the user in different formats in the graph, in table, or any format. So then you need OLAP. Now, what are the examples of OLTP, for example? Now, those are RDBMS systems, for example, SQL, can be Oracle, it can be DB2 or something like that, or MariaDB as well, which is probably replacing MySQL. Then OLAP, it can be Cassandra, which can be which all databases, which wherever we have column databases, like Cassandra is one of them. And then I think what I remember is Redshift is one of them, which maintains the data in for as a data warehouse for analytics purpose integration. And then which all databases it has based on the analytics purpose, or they have columnar kind of storage. So they are basically nothing but OLAP. So these are some of the examples probably which we can explore in some of the other videos as well. But in this video, I just wanted to present about what is normalization and denormalization actually. And it's not the case that in each problem we should only go for normalization, but in some cases we may have to go for denormalization. But we should be aware of these points that before going to denormalization, we should not have certain use cases around this. But if we have certain points around this which we have to suffice as our business requirements, we should think about whether we should use denormalization and normalization in collaboration or either of one. It entirely depends on our business requirements and business goals and drivers, so that which one to prefer and when. Going forward in the other videos, we may go for some other stages as well. So this is one of the kickoff videos which we have started as part of our serverless design going forward. So with this video, probably we are demonstrating or kicking off our one of the sessions going forward on the serverless. So uh, within this video, we have just explained you about the normal SQL based concepts, and in the upcoming videos, we are starting a session or probably different, you can say, playlist of serverless. First of all, we will talk about what is serverless, when to use it, when not to use it, with a proper case study, and then we'll probably go to the hands-on practice as well. We'll discuss about NFRs and all that stuff in our different videos whenever we go to build the chain of the videos. This entire chain of channels, or this entire chain of playlist, is part of our solutioning architecture program which we are already running. So as part of solutioning architecture, this is one of the steps we are taking forward, where we'll be discussing about serverless microservices, which is better in which case, and when to choose based on the NFRs, business requirements, goals, and all that stuff. So this is the extension of those series that we are creating. So we'll be adding more videos in the upcoming days. So please stay tuned to the next videos. Thank you.